So today's topic we are going to discuss about the approaches related to the analysis. As we discussed in the previous classes about use cases, which also helps us to analyze the system because we are trying to understand so many things using use cases. Use cases are nothing but the functional parts which have been defined in the system in the form of a document. Now we are going to see some more analysis part. So the basic objective of this analysis is to obtain or to get a clear idea or clear understanding of the needs of the clients and the users and what exactly it is needed for the software and what are the constraints which have been placed on the solutions based on the problem analysis. So if you try to find any solution for a problem, a general basic principle is used, that is divide and conquer rule is used. That is, according to programming language, one of the programming language like C language or some C++, they have functions as a topic, as a concept. So through functions, what we are able to get from that programming, that is functions are majorly used for dividing the major problem into sub problems. So similarly here also analysis will be made on the basis of general principle like divide and conquer rule by partitioning the problem into several sections and trying to find the solutions individually on the partitioned sections. And the analysis will be made totally, but the analysis will be made totally, but the trying to understand that problem, the partition will be made sub problems. That is a big problem will be divided into sub problems. So during the analysis process, we need to consider so many things regarding the state of the software and projection of the software. So what are these two terms? State of the software and projection of the software. So state of the software is nothing but at what stage the software is going to be developed. That is, we are analyzing the system or the software according to different states of its behaviors. So through analysis, we need to understand several parts of it. One of the part is its state. Its state is nothing but at particular time how it is going to behave, and at another particular time how it is going to be behaving. See, to understand the state, we can analyze in such a way that so as a user's perspective, how it is going to behave, as a uh, developer side, how it is going to be behaving. So these are some of the aspects which will be noted while analyzing. Along with state, there is one more point to be noted, that is projection. Projection is nothing but the point of views which have been demonstrated for a particular software. So a system can be viewed in different views. Let us say that as a user's perspective, it will be giving some kind of information there. Okay. As a developer, the system will be viewed as some kind of a representation. So projecting your software will be different in different scenarios. Okay. This is about the background of analysis process, that is other approaches to analysis process. So one of the approaches is by using a diagram called as data flow diagram. Through this data flow diagram, we can analyze the system in such a way that what sort of inputs are coming into the system and what sort of outputs are we are gaining from the system. So how the problem will be analyzed based on the DFD diagrams, that is data flow diagrams. So the problem analysis will be made in the graphical representations through DFD diagrams. So let us get into the topic. So this is most widely used. Okay, this is most widely used to focus on the functions performed in the system. And it is viewed as a network where the data will be transforming to one stage to the other stage. So data is flowing from one place to the other place. So similarly, when we consider a system as a network, so if we are trying to represent a system as a software system as a network, so what happens in the network? Data will be transferred through the networks from one place to the other place. So similarly, to understand that concept, like transformation of data from one place to the other place, we are using here data flow modeling or data flow diagrams. So to represent them, we are using data flow diagrams. And one more thing, data flow diagrams will make the functional requirements into some kind of sub functional requirements. Let us say that if major functionality of particular software will be viewed as sub problems also, subsystems or sub softwares. So use of data flow diagrams and functional decomposition in modeling. So data flow diagram not only restricted to the problem analysis of software requirement specifications, it has been used before software engineering principles has been designed. It means that before DFDs, before DFDs came into existence, it has been utilized in other issues also, in other parts of the software development, engineering developments. So the major purpose of DFDs are to understand a system, okay, to understand a system through flow of data. So what exactly DFD will show to us? It will show the flow of data through the system, and the system will be getting the inputs to outputs. That is, inputs will be changed as outputs. So here transformations are nothing but the processes or the process to get a particular result. So DFD will catch such kind of transforms or processes which makes the inputs into outputs. And it is not at all limited to the software specifications. It can be any kind of a system analysis will be made. Not only software, we can analyze any type of a system using DFDs. So when we see about some of the conventions which have been used according to the data flow diagrams, that is transforms. Transforms are nothing but process which is represented by named circles or bubbles. We call them as circles or bubbles. So these are some kind of representations which are used in the data flow diagrams. So transforms are called as process. they are represented by circles or bubbles. And the bubbles are connected by arrows on which named data will be traveling. It means an arrow will represent the data is flowing into the transforms or out of the transforms. And there is one more representation is there, a rectangle representation. It is used as a source of input, or it is one kind of a output source also, input and output source, or consumer of data or sender of data. Here we represented rectangle as originator and consumer of data, both. So let us see some of the representations which have been used in the data flow diagrams. So you can see some kind of a curve like a shape that is represented, and the name given for it is data flow, and it is used to connect processes to each other, to source or sinks, to arrowhead indicates direction of data flow. So if you put an arrow at the end of a particular point, then it will be said as data is flowing into that. Either it may be process. So here process is represented in the form of a circle, or we can call it as bubble. So what happens here is the transformation part will be done here itself. It is performs some, we represent them. Actually, it is one kind of a representation, graphical representation. So most of the transformations will be done as part of a process that will be represented in the form of a circle or a bubble. And it will give us some kind of output. Next, rectangle. It will be treated as source of getting data and to store the data also, or to receive outputs also. Next, there is one more representation. A straight line will be used, a double straight line. It is one kind of a data store. Data stores are nothing but the place where we store the data. So it may be a file, it may become some kind of a server where the data can be sent or received. So the repository of data, the arrowhead indicates the net inputs and net outputs to store into it. So it is one kind of a place where data will be stored. Either it may be a data related to inputs or the data related to the outputs also stored at repositories. So majorly the data flow diagrams shows the movement of data through different transformations or processes in the system. As I told you, the processes are named circles and the data flows are represented by named arrows, and rectangles represents source or sink, and it is a net originator or consumer of data. So this is about some of the representations which have been used. Regarding DFD diagrams. So let us see some kind of example. So this example is trying to calculate or trying to give salary to a workers based on some kind of daily wages, or we can consider any kind of a system in which employees are there, they will be paid at the end of the month. So let us consider this example. First of all, we will try to explain about two rectangles in this diagram. There are two rectangles. They are named as worker. So as we said, rectangle is represented as a source or sink. Sink is nothing but output. So what happens with this? So from worker, it is one kind of a place where we get the details of the workers like employee IDs, and if he is a regular worker or a contract worker or time waged worker or some kind of a labor or some kind of types of workers will be there. So this is one kind of details regarding worker. So how many hours he has been working. So all this will be part of this source called as worker, which is represented in the form of a rectangle. So from this source we can get the details of the workers. Here you observe here weekly payment is done here. Okay. So we will get a weekly timesheet for the worker. So for week, how many hours he has been working and what are the pay rates, everything. So the basic output of this DFD diagram is to give the check to the particular worker, which will be stored in the same rectangle shape worker, which is represented as a worker here. Issue the paycheck. In this system, first the employee records is retrieved using the employee ID, which is contained in the timesheet. As you can see here, weekly timesheet is represented here over here. So from weekly timesheet, based on the employee ID, the employee details will be gathered. So from the timesheet, we will get the rate of payment and overtime are obtained. So if he is working more than hours, then the details will be also collected based on the weekly timesheet. So these rates and the regular and overtime hours are used to compute the pay. So after the total pay is determined, so let us say that after the total pay has been determined, so what happens to compute some tax? Let us say that he will have some kind of a tax. So to compute the tax deductions, so we need information regarding tax rate file is used here. So the amount of tax deducted is recorded in the employee and the company records. So whatever details have been processed or whatever details have been gathered, they will be again processed and again stored into employee record as well as the company records. So to deduct taxes, we need some kind of information, that is through the tax rates which are applicable for a particular employee regarding a particular company. So after that, finally, the paycheck is issued for the net pay. The amount paid is also recorded in the company records. So after processing all these things, so get employee file, weekly pay, after that overtime pay, next deduct taxes, then we will get a net pay. So based on the net pay, we will issue a check. So those details, that is how much tax is deducted and how much he has been paid, they will be stored into company records. Along with that, it will be stored into employee record also. So how much tax has been deducted for a particular employee, that will be stored into the employee record also. So after issuing a check, then it is the sync, that is the completion of this task. It is a sync that is called as worker. So this is what an example demonstration of data flow diagram. So you can observe here there are some asterisk symbols are also there. So asterisk symbols are nothing but there are more than one input for a particular process. So to calculate overtime pay, it needs the detail from the employee file and it needs the detail from the weekly pay, and it needs the details of overtime hours which worker has performed based on the weekly timesheet. So there are so many things have been processed over here. So a single process getting more than one input to represent them, asterisk is needed here, and it will be represented in the form of and operation, and operation, you know that in computer organization or some kind of operating some kind of a bitwise operators or some kind of operators will be there, and operation will be done here. So asterisk represent here and operation, overtime hours into pay into overtime rate. What is the rate for the overtime which has been given by a particular company to a particular worker. So to calculate all this are given as input to the overtime pay process. This is all the circles here are representing transformations. Okay, these are all transformations, are also called as processes. So after calculating all the pay regarding issues like overtime, weekly pay, everything, so total pay will be generated after this process, that will be given as input to the deduct taxes process. So deduct taxes process needs information from tax rate file, or the data repository. It is a place where we can get data regarding particular details of taxes. So how much tax will be deducted and what are the rates of the taxes. So on total pay, they will be deducting some taxes. So the result of this deducted taxes will be stored into the employee record as well as the company records. So after storing the details, the output of this process is a net pay. Net pay is a actual salary which the worker will get. And for that, there is one more process will be assigned, that is issuing a check. So issuing check is one more process based on the net pay. A check will be written and it will be given to the worker. Check will be given to the worker, and what can be the details which will be stored into the company records, that is check details will be stored into the company records, like the check number will be there, the person ID, that is employee ID to whom it has been given. So all these details will be stored into the company records. So this is an example of DFD diagram. So according to the diagram, the external files shown as labeled straight lines. Just now we have visited labeled straight lines, company records, employee records, tax rates. These are the straight line external files which are needed to understand the system. Here the system is paying the worker the salary, that is the salary which is to be paid for the worker. So need for multiple data flows by a process represented by star, that is asterisk symbol, means and operation. If it is plus, if diagram contains any plus symbol, then it will be called as or relationship, this or that. So all the processes and arrows should be named. Compulsory, they should have a name for a process and arrows which have been demonstrated in the DFD diagrams. So process should represent transforms, arrows should represent some data. Okay. Next, major focus will be made on transforms, that is processes. So how they are going to be done, that is not important, but the flow of data. See, we are not concentrating on what is the internal details of overtime pay, deducting taxes, issuing check. See, just now I told you what is this process may contain. what sort of data will be sent to the company records. That is not important for us, but the process named as issuing a check, that's it. So the internal details may not be important at this diagrammatic representation. So that is what is said here. Focus will be on the transformation happening, but they will not concentrate on, that is, internal details will not be made. So usually major inputs and outputs shown and the minor will be ignored in this modeling. So see what sort of inputs can be called as major inputs and what sort of outputs are called as major outputs. It will be depend upon the system which are important for us. Such kind of inputs will be gathered. Which are not important, they will be ignored in this diagram. And one more thing, when you are processing inputs or when you are storing outputs or getting outputs, don't think of some kind of looping or conditional thinking will be made as part of DFD diagrams. That is, there will not be any kind of a loop strategies like here we need a loop. That is, programming strategy will not be used here. It is only a representation. So DFD is not a control chart, not algorithmic design thinking. It is just a representation what happens with a particular data getting into a particular process. That's it. The diagrammatic representation will be done. Next, let us see. Just now we have visited an example regarding some kind of DFD diagram regarding pays to the workers. So what all needed to draw a particular DFD diagram to a system? So to draw a DFD diagram for a particular system, first of all, we need to identify what are the inputs, outputs, sources, where the data can be retrieved or where the data can be stored. All these sources will be identified. So next, a high level transformation. So after identifying inputs, outputs, sources, things of the system, then try to define the processes. So name some processes. So identify the processes which will be taking care of all these inputs, outputs. Next, if there is one kind of a blocking of resources, then what happens? Go to the starting and again draw the diagram. So this is about drawing the DFD diagrams. Never show control logic if thinking in terms of loops, decisions, stop and restart. That is what said. Don't use programming strategies. If you are thinking that this has been used, that is programming strategy has been used, so then and there itself you have to stop it and then restart drawing it. Then an important point, that is label each arrows and bubbles carefully and identify inputs and outputs of each transform. So not only we are drawing all those things, you have to label them, if the arrows, bubbles, everything. And one more thing, after processing of each transform, carefully identify the inputs and outputs of it and make use of, that is, arithmetic operators like plus and asterisk. And asterisk, these are the two operators which have been represented in the diagram. So these are some of the things which are needed for drawing DFD diagrams. So DFD diagrams can be drawn in different levels, because let us say that we have a huge project. Let us say that a project is huge. So in a single DFD diagram, it cannot be represented. So what we have to do? It should be overall picture, overall diagram will be drawn first. Then based on overall diagram, we will be classifying several sub diagrams also. So all these are called as levels of diagram. So DFDs will have different types of levels of diagram. The first diagram, that is called as a context diagram, which will be defining the system. the basic system, that is a root for the levels of the diagram. And based on that context diagram which has been defined or drawn, the remaining diagrams will be represented. So DFD of a system may be very large. So to organize it, we have to do some kind of a leveling with a few bubbles, then draw DFD for each bubble. That is, we are trying to identify main system as one transform, then divide it into several transforms. So make drawing the level DFDs a top-down refinement approach. That is, the major process will be at the top, the remaining sub process will be at the bottom. So top-down approach will be used here. So after drawing all those things, see, we are discussing all these things as part of SRS only. So SRS, all these are part of SRS only. So now all the requirements which have been gathered, they should be validated. Okay, whatever requirements have been gathered, whichever are represented in different ways. So analysis, all the things have been done. So other important aspects are, if you the requirements which have been misunderstood may lead to errors in the SRS, or SRS will be of most of errors. So most of the common errors which can be encountered in SRS preparation are omission. Omission is nothing but removing without considering some of the things. You start preparing the SRS document. That will be 30% of. So it will lead to 30% of errors in the SRS. Next, inconsistency. So it will not perform any consistent strategies. It will not follow any kind of rules. So it may lead to 10 to 30% of the SRS errors. And incorrect fact, that is, whatever requirements are there, they are not properly represented. You are representing the requirements in another way, what actually it has been. So it may lead to 10 to 30% also. Ambiguity, there should be some kind of a confusion. So if the confusions are there in the SRS document, that may lead to 5 to 20% of errors in the requirements which have been gathered. Next, review. So requirements will be reviewed after preparing the document. Then SRS will be reviewed by a group of people. The group of people may be the author of the SRS preparation, and a client will be there, user will be there. Along with that, development team representations are also the representatives. So these group of people will be reviewing the SRS, and it also includes clients and users. So process will be inspecting all the things, and effectiveness can catch about 40 to 80% of the requirement errors. So all these reviews strategies will be made. Next, this is our summary which we have discussed so far. That is, to have a good SRS quality, which is essential for quality and a product of the software. Every requirement phase has three major subphases like analysis, specification, and validation. So under analysis, we are trying to understand the problem and modeling so many things by using several methods like object-oriented analysis. We have used some kind of use cases, DFD diagrams, all these things. And one major properties which are related to SRS are correctness, completeness, consistency, and ambiguous, as we discussed in the previous classes. These are the key important points. Next, under specifications. So it must contain all the functionality related issues, performance issues. So performance specifications should be there, functionality specifications will be there, interfaces and design constraints are also considered. So all these specifications are done in natural languages which have been used. Along with the natural languages, you have to specify use cases for the functionality, and the validation can be done through reviews by the group of people which are meant for. This is about second unit, first topic SRS. So in the next class, we are going to discuss software architecture, the second part of the second unit. This is all for today. Thank you.